Oh, we're making a grid now. Cool. Next phase. That's okay. I have it on. Yeah, so... Oh, right. Okay, I'll show progress from last time. And then goal is... I guess you could call this like goal. We do grid. Let's open it up at the top. I had to help not to help you, because I don't know where things are. Comment. But yeah, we'll use an action. So this is okay, so there are like a couple coordinate systems. This is the most obvious one, to be honest, like the offset one. This doesn't quite work, because this is now row 3, right? But you see, it's a little bit janky. So this is like a column one based on absolutely nothing. The same for the row. So 6. Oh, actually the rows are kind of, these are at least all the same line. Columns are so janky. Yeah, cube one is kind of beautiful actually, because it like fans out. So this will have like +1, -1. It just keeps on fanning out in full cube. Problem with this one is that it has one label too many. So like you can get away with dropping one only on 2D plane. So then you can use axial system. That's what we're gonna use. Simple. So one axial here and another axial, and we basically offset the bestest 3. Welcome back, Lumi. How are you doing, man? Yeah, that's cool. I probably should get some. Had an internet outage all day. My god, where do you live? Finally back home. You probably binge interneting now then. That's awful. Let's actually read about the actual. Yeah, we don't need to do this. I already decided before I want to do a double tandem. But yeah, I already decided before to use the actual. He basically recommends it. And it also looks the most elegant to me. So yeah, unless someone in chat would say like, oh no, don't use axial. Killed my mother, they killed my father. And yeah, finally back up. Good. Like, take away your internet, man. I would start plotting a rebellion. Take away my internet. Can't do that. Like basic human rights. The actual coordinates, trapezoidal oblique skewed is built on cube. You have a constraint, blah. Oh, he's actually telling that you can drop one here. Probably where I get it from. I'm not that clever. I don't really care that much about hexagons as I pretend to. This diagram is the same as previous, except it doesn't. Why? There are many choices of cube coordinate system, many choices of axial coordinates. Well, that sucks. I just want to have one. Guess not. We'll use axial. Okay, so how do we go from choosing a coordinate system to actually rendering it on screen, right? And I'm thinking like, okay, maybe we can do like vector, right? So we'll do like data is coordinates, and we'll do like grid here, which will be like a vector. But what do we put in here, right? That's not a question to answer. And I already thought about this before, and that would be a tile. Data tile. Wait, this doesn't make. Does it? Well, maybe, okay, if we put a limit on how big our map size will be, we can use the vector to store everything basically. The tile will be tile A. Maybe that's it. Maybe that's tile. I guess you're more of a new type then. Same for you. But the vector will be all A. You want to do it? I don't know. I don't think we want to do it. Like, it's a pain in the ass existential. Sounds good in theory, but it's okay. What is your? Let's be. I don't know. Let's call this like delta. We can put anything we want in. Maybe we don't even want to do this yet. Maybe we want to make like a tile. Yeah. This seems simple. Okay. And then like we do the obvious thing here. We'll give it a x. Just a C and Y. I'm thinking like we can add that tag of polymorphism later if you're gonna put stuff in it, but we're not gonna do it yet. Want to do it. Okay. I wouldn't know neighbors. I guess we define our grid mostly through our morphisms, not so much the data, because the data is always similar. Actually, he calls us Q and R, not so much X and Y. Maybe we should copy that. I liked it. And maybe we should also put this into separate. I like that idea. Because we're no longer really dealing with the hexagons themselves. Now we're just dealing with, I guess, logical representation of the hexagon. And at some point we want to make a function to go from tile to hexagon setting. So we'll have some function that does this. And this function does the mapping from tile Q. Where do you put it on screen? But that's for later. I guess that's rendered. Coordinates. Tile. Maybe we want to call this stat. First we want to replace hexagon base coordinates. We want to call this thing. File hex coordinates. This is advantage vector. Cleared. Map storage. One of the most common complaints about axial coordinates is that it leads wasted space using a rectangle map. I don't care about that. Wasted space with triangle. Accept this same strategy. I don't want to make an array of. I guess we need to figure out how big Q is, how big R is. So if we know how big Q is, we can. And if we know how big R is, we know how big can. So we can basically like calculate offsets. But as you can see here, there may be no coordinates. So we need to be able to tell it. Vector has maybe two. We don't all. Well, I guess vector already provides that. Don't always return a value in vector. Safe indexing. That's why is this safe? Gee, let's implement this here or something. That vector generic. What? You're just checking for the bounds. Check. What's this? I wonder if you were able to set, why is this a cycle? Build the element of the given position in the monad. No range checks are on. It allows us to strict in the vector. Suppose we had instead now we want to copy a vector. Yeah, well, you know, game dev, right? You have to kind of know. Like my question is, can we input empty values? Because this is an array, this is not a list. So do we want to be able to do maybe tile? Or do we want to do tile and then let vector maybe? Let me ask like this. Can we insert, maybe I want to use an int map, just a map. If you have bounds, parse, now I don't know what it means, parse vector. It's confusing. It is cool. We are trying to make this, so like this one, what I'm having my mouse over right now, left here. This is what we're trying to render. And this is how it looks in memory. So what my question is, like, is this null built into vector? Can we represent that like a map? Or is this not built in? So we need to just make, you know what, like if we're unsure about this, why don't we just use a map? Not like we're having any performance issues right now. So why bother, right? Continuous or sparse. Sparse is when they have holes, may not have holes. Many sparse vectors, various kinds of mapping. Wait, sparse is without, or sparse is with holes. This thing, I'm pretty sure this is just a block of memory in C. Parse is with hole. Issues. How about this? Quite unhappy with that. I don't know. I thought my tile data structure would be more glorious than just the coordinates, but that's what we have right now. I'm gonna get some driving. Okay, and like I guess we want to have like an initial. Go to from 1 to say K. I don't know what the difference is saying. So we'll do zip size. That's all. Oh, we're all about time. Welcome back, Skybro. How are you doing this time, right? I think I haven't streamed in a while. We have to finish this game at some point and spend a little time on it. We'll get some. You eventually need all values stored. The stored values don't represent large field lazily computed. It's gay. I don't like the game. Oh, we need to put it into a grid. Okay. What does it mean? It doesn't use all the values. That's like if you want to put it into, that's fine. Oh, 0.0 doesn't exist. Of course. Because you offset everything. Maybe we should make it 6 instead of go to line. My god, there's a lot of stuff. I guess we want to go hex to size and spacing. Yeah, we did this. We know how to do axial coordinate. Okay. For axial coordinate, think about hex to pixel, basis arrow, Q basis. What? At basis vectors. Oh, it's the origin. So we are moving 1 unit on the Q axis. So that's like the basis. Going 1 unit up, going 1 unit the other one. That's our basis. Okay, thank you for telling me that. Love me some basis. Do you know what a basis vector is? Did I kind of guess it right? Why is it square root of x? X is square root. Why is? Oh, because you're calculating geometry out of it. Chemists love basis vectors. It's for like sour basic reaction or something. Sour! Don't let them react with you. Run sour. Our optical wants to react you. He's a chemist. He likes to make sour basis reactions because of all the basis vectors. Well, base, right? I'll get some drink. Be right back. Oh, that's the fungi I put into milk. It gives me like yogurt. I'm good, man. Let's see. Your job, I mean. Epic Haskell job. Still doing yes with practice. You don't need to practice. Yes, it's kind of boring, right? It is. It is kind of boring. I'm using Yesel as well. I don't like how popular. The servant beam combination. You know what we should do as well, maybe? Compile our code. We haven't done it in a while. It's probably full of bugs. I sometimes forget I actually have to check it to make sure it's right. Oh, we're not even using DHCI here. Oh, and the other thing is we need to make the... so we need to tell Cabal about the new module because kind of dumb about. I'm preparing stuff for what Sour is doing. Sour has like a slow cooker, so he can make... He has this like Romanian delicacy, like putting meat into... Is it? I forgot the name of it. Putting it into the slow cook, great idea. Like some kind of fetch, put it around the star mount. Yeah, that's it. The chemistry basic sets are groups functions that are used to build a wave function. Each basis function has weight associated. This is exactly right function. Why do you need a wave function? Each basis function weight associated. It's kind of related. So in geometry, draw a circle around axial coordinate. What they're doing here is conversion from QR coordinate system, XY. So XY is straight like this, and QR is this because of the hexagon. If you look at the one, I need to stare at it. Not that quick. Yeah. So we have like the grids are not straight. So what they're doing in that pixel to, I guess, hex to pixel, they are making these lines straight again. And that's because of circle. I'm not making it. I'm sorry. I can't explain any of it. But because it's a circle, it's also a wave. Because sine is sine and wave. It's all related. shaking divided by energy, weight, basis. I think they're already some, like geometry. I think they even yeah, they throw the matrix, but it's kind of the wrong way around because you started with Q and R. So you have to divide both sides by Q. Oh, you have to divide size by blah and then blah blah blah. And Q and R is everything divided, right? Because we're starting with Q and R. This is not quick math. This is just regular math. At least I thought the quick math was doing more magical. Right, we don't know about hex setting. Didn't import it. That's kind of problem. I think this should be a like we want to depend on everywhere else. We're rendering it later. Well, actually, right now, to think of it, we render a single tile into hexagon setting. The tile has the coordinate tile Q, tile R, and if we can render a single tile, we can render. Why is this still here? Right. So we have hexagon setting. This hexagon settings thing. This is like all the information you need to make a rendering of something, right? So you get the position. This is what we're trying to calculate right now. The size, this will be default, so we actually won't override. And then a label, which we added last week, so we can actually see the Q and R. So the position here is X and Y point. But the position here is Q and R because we're still in the actual. So I want to put those Q and R into this so we at least know where it should be. Mods, man. Go bro. Sorry. I don't even want to become kind of obnoxious at the pre-file here. There's a user like spamming our help. I could have done it myself. I'll just do it myself. They're both sleeping. My god. Okay, so we need to right before I could. Well, thanks for the effort at least. That's nice. We need to make a point out of it, and we need to. Not a point. I'm just like reading the book. You know, we could do it badly. We can put the I'm like lightning fast with my ban trickery. I was zoomed out or zoned out. However, we should drink less of that healthy. Tile Q. How are they related, to be honest? Oh, X. So want to make an X out of it. We need to multiply the size. We know the size. We know the size. So we have to take the size, multiply the entire thing with that. Alright, that's for X. What? Oh, I guess we also only want to get size X. Let's just calculate X. Let's say X is this is gonna get hexagon size X times tile Q. Square root of 3 times Q. Hello Contorn, how are you doing? Is the one a bot? No, Contorn is real people, I think. He's Nix expert, remember? He's actually way better at Nix than I, like hacker. I think he made like Visual Code in Nix, like all the plugins and stuff in Visual, and like one big ass. May the Nix be with you. Thank you. Oh, actually, I had my had a cool project. I don't know, interesting. I had my talk. Turns out it actually does thing. It makes out of the org document reveal.js completely with real sources ever. Pretty cool. That's my Nix story. I don't even remember doing that. That was like last year apparently. Yeah, I stole it for some. I probably stole it from someone. UX better. Exactly what the bot would say. God, Contorn, are you a bot? Watch that. We haven't copied over the Belch. How do we even do square root? I guess square root is more of a double. Square root has. I guess you can do power half. You get a square root, right? I think that's how it works. You just it's in prelude. Yep, go. I am the bot apparently. Well, Skybro, we know you're a bot. That's why you become a moderator, right? You're trustworthy. So let's see. We need to do square root of 3 times hex Q. I guess we need to do like Q size times. And then we need to do square root of 3 divided by 2 times R. Doesn't make any sense. But is it plus? Plus. Okay. 2 times R. Okay. Then the other thing is we actually haven't got lens. Well, you know what? I want to produce a lens of dash. Oh, optical. Your cat got adapted again. You define the hack list of lists. Eh? I don't define. Yeah, Skybro is a real hero. He's been adopting cats like crazy lately. I bet his house is full of cats. Find the hacks list of lists. Show it you. This stuff? Matrix. Ignore him. Math. Nobody cares. Oh, we need to also do times hex R. Oh, we already did that. My god, we're already done by the way. Fast. Oh, it's just what? It's 3 divided by 2 times hex pointed. We have pointed up, I forgot. We can't build right now. So both make match style. That's okay. We can figure this out. Everything works. Find but not use size. Oh, we haven't used initial grid yet. Right, can export it. This is our ad hoc level, by the way. This is the level. Just tiles. We'll get there. Okay, we'll make an entire world. Like, don't you worry. Don't you worry. We just have to start with, you know, the floor, basically, to put stuff on. You're not gonna build your house by starting with the roof. You have to start with the floor. You don't know about the code. Just do all this point. Oh, because okay. We need to put it into the point objective. Oh, okay. Probably a bunch of precedent stuff. tell us what to do. Oh, this is copy. Did it work? Oh, you need to right, we need to round you. We need to round you later on, to be honest. It's better if you go from into and then we round you at the end. Floor, I mean. We're game devs, so we use floor. We don't round. We need to keep that if we start rounding here, we won't get any advantage. Oh, yeah, proper floating like a double int. Oh, let's not do y yet. Oh, that's just the whole. Oh, we actually fixed the x one. Aren't we lucky? Just did something. Y is actually a lot easier, honest. Just 3 divided by 2 times hex. Maybe because it's already like a lot closer. So we got 3 divided by 2 at time from file. Fine. Division has precedent. Oh, you don't know which type it is. Right. We need to make one of you double. We could use more precise types. Pink floating point, and we did. Okay, we can render a tile. Now let's render a grid. We'll just traverse it, I guess. That's it. We go to the guest and we first, and that's how babies are born. So we'll do hexagon dot the grid. Then the grid's initial. This should show us how baby. I think traverse is from data flow. Because like you don't get the one with the dash by default. You only get the one that they don't want us to have nice render tile. Oh, we didn't export it. Oh, the max type. Oh, we did that. That's kind of dumb. Well, I guess you're gonna be a map of tile. Look up like let's make it. I want to have a map. I have a map, but you can figure out what you are. It's kind of a pointless map because a map of things that points to well. It's an endo map. Oh my god, aren't I? With cut the look at that stuff being rendered. Oh, we also need to set a label, to be honest. That's quite important because we don't know which is what. Amazing. It is, isn't it? The miracle of life. Label. I want to do like tile. It'll be shitty. Just printf tile. Printf tile. I don't know which one comes first. Q or R? I think Q. Yeah, it's like alphabet. R. You can't focus on it during work. Yes, it's too hard because they're talking. You kind of want to. It's not like a stream where it's just kind of mumble. Someone has subject, agenda. Well, it's bad. Hard to. It's yeah, because like, but it's interesting. Even like the ancient one, I really enjoyed those episodes because it's just like some dudes like, kind of thinking about random stuff. It was just considered already philosophy. Like scientists studying these guys that are just doing something. It cracks me up basically. Someone going through these ancient texts. I think these silly right. Well, I'll listen to one of those old ones. I remember it being kind of funny, but data printf, that doesn't sound right. Text printf. I've been starting to use that printf way more of the show use. Hexagon label. Hexagon. You can't make a text. I'll see your preferred way of writing. In Skybro, I saw it. Need to tag. Why are you text? Oh, yeah. We only imported the type text. We didn't actually import the qualified. So handy. Clearly X style XX. I wonder why it's like drawn all the way up there. They're so far apart as well. It doesn't seem right. Protocol go. Oh, we did. And you not right there, but right in. We can move you. There we go. We have now. You go to. Good job. Ranger notify. I think our file function wrong. I want to make commit first because we have something. It's starting to kind of look like what we want, and like even though it's not exactly what we want, any progress forward, take it in, and it compiles as well. So technically, it's correct, right? To make. Imagine writing Python. I have not written Python. Okay, let's see. What the join file? Think that works? Join. What? This works? It's not even shorter. It's not even shorter. I bet this is not gonna work. No way. Doesn't know about join. We need to import control of monad. Doesn't even know about it. It works! That's beautiful. Oh my god. Join though. But it's beautiful. Also we have hexagons. Didn't have shown. Ah yeah. Yeah, this is one of the reasons I like types. Dynamically typed language I run in my spell error. Can't fix them. It's super readable, it's probably. How does it work? MA. Why do you need to join tile? Oh, because tile is actually of. So if we join tile, we'll get into tile. Obviously. Is that it? It is! That's so cool. I love it. Join again, right? And put to one tile there. Not with dot. That's bad. It's a part like more beautiful. More characters. You want to have the spaceship. Needs to have the spaceship ice cream cone. It's the rule of life. Beautiful. Okay. So we're doing something wrong here. I just like kind of went over it in a rage, trying to figure out how everything, but that was too fast. We need to study this, whatever this code is. Python. Oh, this is Python code. Oh, it is Python code. I didn't even realize. I thought it was like some kind of, I don't know, think about it. I thought like Lua or something. That isn't Python. Oh, maybe it's Lua then. Yeah, it's not Python. It looks like Python. Oh, too long. And maybe it is Lua then. We take the square root of 3, we multiply it by hex cube. We multiplied both by size. We only multiplied the 1 by size. But here's the confusing part. We don't know what size is. We enforce the process of hex to pixel. What is size? I think it's Lua code then, probably. What you would show it. Make a variable. Hex. It should do something, like at least put the grid more over the screen. Where are the others? Oh, we're actually not making a T product. We are only zipping the 0, 0, 1. Obvious. That's not good. We need to make a T that. We can use set. Okay. You can use a list compressor. Oh, actually, no, we can use the monad. It looks like cool. So rather than fmap, we will we'll do R and cure. No. What am I doing? Oh, I can't even do it like that. No, don't do Tuxedo. They kind of suck. They gave me like the older one. They tricked me into getting an older laptop. I got like a model from 2011, like 2015. And then like 2 months later, they release a new version. God damn it. Okay. Oh, maybe you're being censored because Tuxedo is such a shitty service. Never buy anything. Use BTO. Much better. I like them. They're a bit more expensive. Oh my god. That looks like a grid, no? Yeah, Altern, you're seeing the birth of a new life here. Welcome. How are you doing now? Into System 7. 66.7 is super. And again, this is dollars. New project. It's kind of worked on this for 2 weeks now. In one stream, we basically explored how to do anything, how Reflex and SDL work. Then I got like kind of hooked and couldn't stop thinking about the hexagons. So we made also the labels. The week later, I think. We're using now here. Now we're like making a grid, so I have like a world to play with, basically. Something we can easily. I don't know about size. Maybe it's 80 times 45. I would assume this is like size X. This will just patch it. For whatever reason, we haven't kind of so fix it. Why? That's better. Still too far apart. I don't know. I don't get what. X. Maybe divide it by 2. That's too much. Okay. Divide by 3 we'll get more. Some. Oh, it can. This looks better. Actually, to be honest, it looks like our rendering is. Doesn't quite. No, you know what? It needs to be there needs to be a bit more vertical space and a bit less. So what if we set the size to 40/40? Get the impression that about that. Oh. Is this the point where we just fiddle it into place? Be happy with it? It needs to have a bit. I don't know. Looks pretty good to me. No, there is some overlap. How annoying. Their basis factors. I don't know. Nothing to do with the molecule. Okay. How annoying. Maybe if we only draw like these 3 and not draw the other ones, and then it becomes like a grid. I don't know. Where is the overlap? You know, we have to look at the. So maybe there's like a little bit. They're a little bit too close. A little bit too close. So maybe if we do a bit more size, the x-axis a little bit farther apart. Okay, that's a bit better. That's a bit better. You're too far again. Are you too far again? So we need to be a little bit closer. A little bit closer. So I guess it's like 50. Pretty sure this is perfect. Pretty sure. Maybe the height is not quite right. What are basis factors again? Those are probably the factors you need to divide. I think so. I think I need to divide by a square root. But this is about x. We already did the translation to x coordinate. Now we're just multiplying by size. It's like scaling. So it scales linear. It's just like, okay, we have a translation done here, presumably, and make it go bigger by multiplying by 1 divided by square root of 2. Oh, you're like a mathematician. Did you study this? What about the other one? That does look perfect. You are right. What about the other one? What about the I don't know. Multiply by 2? Maybe it's 2 times. It's the y-axis. You did the x-axis. There are 2. Pay attention. X, y. Say it's like, oh, times 6. 2 divided by square root of 3. Where are you getting this from? I'll just believe you. Okay. That ain't right. Looks pretty cool. They did it wrong. It's 3. Oh, well, no, we're making it bigger. Maybe it's also 1. 2 divided by 3. We're just getting things. Paste that article. It's a big article. Like, don't try to read. I would say it's 3 divided by 2, but that seems a bit dumb. Because then you make it bigger, right? 3 divided by 2. It's bigger than 1, and then it will be way too far apart. It looks really cool though. I like that part. That's something like maybe it's 0. It doesn't need to be perfect. The game. Oh, it looks like there's too much light. Maybe it's 8, 7. Well, 1 divided by 2 divided by 3. It looks good now, right? Yeah, we have some other problems. Actually, this is fine too. Like we can decide to make a proper square out of it. We could also just keep those constant. The other thing is like our camera something that's actually like involves really cool. Let's look at this. The grid now. Like the next logical step is figure out clicking, I think, because this is good enough for me. So now I want to know if my mouse clicks here of these tiles, or like, you know, maybe click outside grid. Also, and the other thing you want to probably implement planning, so you can move around them. But I'm happy with this as a grid, and so that will make this start done. Actually, this is a bit wonky. Maybe we should get the absolute value out. Just like we also want to use this same mathematics to figure out where we're clicking tile. That's also really precise. But I think we're going to do clicking next. So the session has been quite... Maybe take a small break. Can do click detection. Pretty good. I want to at least get some progress. Because if you have like click detection, you kind of already have the beginning of it. And you can actually start implementing to the point. Divided by size. There you have size again. But it's just some constant. Because we can make the size, make it not part of the tile at all. Renders. We calculated size now. Should be fine. Pixel to point here. Here we have a function that will give us some point. T2. Will give us some function. Oh, this is what we do. We detect the point T2. We get out a tile. We can always do this, right? But what we don't know is this tile is actually inside the grid. So what our grid is used for is to detect if this is even part of our world. This is more like a world, to be honest. We get out the tile, we send the tile to the grid, and then ask the grid, hey, do you exist, guy? And the grid will say, yeah or no. Actually, I think it looks kind of... I was afraid it starts to deviate. Let's remove those buttons. We know how to do, like, we have like lots of thing out the shares, button, also delete button. We don't need Hexagon. No. I actually want to keep you around. I want you. Size is the distance from the center corner. What? You mean of my window? Where do you find that? This corner is size away from center. Why would you draw it like this? But ours not really regular. That's the way I'm drawing it. I start at the top point, and then go to there, and then there, then there, then go to there, then I go to there, and then I call it a day. I just did something. But here they're like, oh, you need to use sinus and cosines. And I'm like, no, man, slow. Too slow for me. I don't know. I didn't really read it. That's why the math, it does work. What are you talking about? Did you see it work? Working. Good enough, right? It's pretty. The real question is, why does it get cut off here? Oh, I know why. The window isn't bigger. And now it needs, because of I3. I3 puts it into a tile. But like the click detection is also why we don't have labels. Now, see what we're clicking on. I'll take a quick break. Be right back. Hard to believe. It's pretty slow. Say that like, oh, this game won't be fast enough. But for what I have in mind, plenty of fast. Because, you know, I want to do something that's too slow for Reflex, or I won't do it. It will always be fast enough. You're saying when you should use sin and cosine, but I don't really want to rewrite it because it's kind of working right now. And unless we find something that doesn't, like, we get bugs out of it or whatever, then we probably should. We're not there yet. Like, we haven't proven that. Like, we might as well. I need to know Q is an int. I need to know R is an int. Reference. No Haskell. The hell. What's hacks? Generated code. This is the way to write Java. It's beautiful. There's something else. I looked at this. It doesn't do that. Basically type level. And if you come to me with an FPL like this, I'm just like, fuck you. I'm not gonna use this. Let someone else figure this out. This is too much for me. I don't care. You don't have to deal with Reflex, you know? At some point you just gotta draw again. Fucking read. You figure out this library, you know? I like how he uses some dims as natural numbers and use an unbounded vector. This entire thing is useless. The math does work. What are you talking about? You see it rendering, right? Oh, God. Okay, just a little bit. Stop. No, but point. I hate that point. It is legitimate grid, math works, everything cool, okay? It's almost perfect. Yeah, nice math indeed. It looks good. Where's your grid, okay? Where's your grid? You know? You just sit there, have like easy criticism, and then do nothing. Where's your grid, man? You can have big worths once you implement your own grid. I have many. Okay. Can you show like one? It's not a hard task. Okay, what are we even doing? We want to go from pixel to hex. We did hex to pixel, now we want to do it from pixel to hex. We need to divide the square root by 3. My god, your boss is quite awful. Doesn't even allow you to open source, doesn't allow you to make problems. Solve problems in a cool way. Actually, my boss, he published a blog post about lenses. That was pretty cool. Advocating the use of lenses in help. I love it. I love that kind of attitude. Oh, right, do you want to get like... Yeah, it is. Optical can help you prove things, I think. You're good at it. So this is for Q, right? Yeah, Q. Modify by point. I suspect that we don't even have to do this like X. I lost the tile. X. V2 should have 2 arguments. I don't know if this works. It's gonna be point. Q, R. I don't know. I don't know how to get rid of points. It's kind of annoying. point. Oh, the constructor is P. We put it into a P and we put it into that. Okay. Maybe we'll call you Y and we'll like, I don't know. We'll call you integral. Okay. Oh, this is the wrong one. The square root of 3 divided by 3 times point x minus 1 divided by times y minus 1 divided by 3 times I divided by psi. Now here's the thing. You know, let's just make these popular. But what is size? Because now we have Q and R. Oh, I understand what's. We need to do 1/3 of y. And we need to do square root of 3 divided by 3x. Does anyone understand it? I think we just need to define a size and start using it to draw the thing. We can use cosinus and sine. It's no big deal. We can draw this, but we have a size not the same. We can just fiddle around with it. It's not like the size we are basing it upon is not the size. Maybe we can calculate. It's half x. Hexagons are 6-sided polygons. They never say how you render it. Pixel art for hexagons. Stretch or shrunk. Stretch. Yeah, I'm stretcher. Cube versus x. Rename can become the others. But do you want to store the third one as viewed in accessor is primary? Cause cell the most accesses versus cost of computation. Let me just like see plus the access are inlined anyway. Show on the faster side. Okay. Don't really want to read it, but we don't know what size. I need to think about this. I think I want to go on later on the improper. So we could like see how far we can get size. Or we don't need to make it general. So we might as well divide by some number. And if it's close enough, then it's close enough. Doesn't need to be perfect. Doesn't need to be perfect. Let's just continue. We'll assume Q is X and R is Y and just deal with it. We'll add like a comment. Implement size math. Just did some. I was thinking like we could even quick check this shit technically, because you can like get the coordinates out of the and can put it back into here and then see if the tile that comes out is the same as the tile being, and that's just for a whole bunch of random. That'd be good. We could. That's like a really good idea. See how crazy you are. Well, I like that. That's a quick check. For all tile. Tile render is equal to tile. Not quite right because the types aren't quite like, but I'm gonna end. Thanks everyone for watching. We'll go back to this soon enough. I'd love to. But we have some progress. We at least can render some. Let's at least make it build again. Oh, it's already built. We have a grid and we have some progress. Thanks for watching. Maybe off stream I'll rewrite the render logic sinus. Maybe I'll look at the implementation that he made and see how he draws this. I'm so happy this worked on first try. Nice. We have to really that's not quite. One of the problems is that I think if we use Pythagoras, because we're actually drawing it sort of. If we use like Pythagoras theorem and then use the half of that, then we get the size. This should be like a square, not a rectangle. But we're stretched. We have the aspect rate. Okay, it's all complicated. It's like not mathematics, right? It's real world stuff. So you have to deal with a lot of random shit. Yeah, not having that size as a variable is kind of annoying. So I'm just thinking of how can we get that reliably. But yeah. Thanks for watching. I'm gonna quit now. I jabbered on long enough. We have progress. I'm happy with that. I can sleep well. Bye.